My name is Deepa RB, lecturer in chemistry, KD College, Bangalore. So today I am going to tell you about some information about practicals. That is, we have to detect a semi-micro qualitative analysis of simple inorganic salt. So these days you all have been doing online classes. So today we are going to send you those videos of practicals as well. So now what we are going to do in this practical is, we are going to take a simple salt and we would detect which is the acid present in the salt as which are the bases present in the salt. So already I have mentioned I have taken a simple salt, that means you have only one acid and one base. So you have to detect it systematically, that is order wise, and find out which is the acid radical and which is the basic radical. So basically there are three terms what you have to do in this practical, that is, first is the preliminary test, second is to detect the acid radical, and the third is to detect the basic radicals. So let us first start with the preliminary test. So here I have written the preliminary test. One is the state, the color, as well as the solubility. State. So I have taken the salt in this watch glass. So when I touch this salt, I can feel the crystals. So the state itself tells that it is crystalline in nature. So I have written the salt given over here is crystalline in nature. There are salts which also amorphous in nature. It is a powdered like. So if the salt given is crystalline, you have to write it as crystalline. If it is amorphous, you have to write it as amorphous. So the salt which I have taken is crystalline. So because of that, I have written it as crystalline. So next, when we see this salt, you can see it is white in color. But you don't have to write white in color, but you have to write it as colorless. Okay. So here, I have already written over here that the color of this salt given is colorless. Yes. So there are salts which are colored in nature as well. For example, manganese. Manganese is pale in color. So by seeing the color, we can detect which salt is given. In case of manganese, if it is pale pink, that tells you that it is manganese. So here the salt is colorless. So next we'll go for the solubility test. Solubility test, what you have to do is, you have to take a test tube. To this test tube, you have to add a small amount of salt. As I have already mentioned, it is semi-micro. So you have to do this practicals in small quantity. Okay students, so I have already taken some of the salt in this test tube. To this test tube, you have to add water to it in order to find the solubility. So here, as you can see, I have written three cases. If suppose the salt is not soluble in water, then you have to detect for dilute HCl, then go for HNO3. So first, we will go for water and see whether it is soluble or not. So I have taken the salt and I have added water to it, shake for a while, then you can see the salt is soluble in water. So now what you have to do is, it is soluble in cold condition, so you have to mark it as tick. This much is more than enough. So it indicates that the salt given to you is soluble in water. Then it is already soluble in water, so no need of doing this solubility for HCl as well as HNO3. Okay, so you have to stop it till up to water. So in the exams as well, to perform the preliminary test, that is the state, color and solubility, this will fetch you 1 mark. So preliminary test itself consists of 1 mark. Yes, this was about preliminary test. Now, next is to analyze the acid radical. So, preliminary test is over. Then second one is to analysis of radical you have to detect in terms of groups. So here also we have to first detect the presence, then you have to confirm and see which acid radical is present. So let us start with the analysis of first group acid radical. Analysis of first group acid radical. So here in a test tube you have to take a small amount of salt, and to this you have to add dilute HCl solution. So this is hydrochloric acid which is dilute in nature, and to this salt you have to add dilute HCl. So when I added dilute HCl in the test tube, there won't be any reaction. Okay, if suppose the carbonate was present, it would give a brisk effervescence. But here there is no reaction taking place, neither the effervescence or neither any reaction has been taken place. So that itself indicates that carbonate is present. I would like to give you a small hint that if the salt is amorphous in nature, that indicates that carbonate is present. But here there is no effervescence, that itself tells that carbonate is absent. So here the first group acid radical carbonate is absent. So here you have to draw 3 columns. One is the test, another one is the observation, and next is inference. So in the test column you have to write what all you have added to the test tube. So that is salt plus dilute HCl. Salt plus dilute HCl. When you added salt and dilute HCl, you did not get any effervescence, so you have to write no effervescence. No effervescence. So in the inference column, you have to write first group acid radical CO3 2 minus is absent. First group acid radical CO3 2 minus, that is carbonate, is absent. So after the first group analysis, we have to detect for the second group acid radical. So next you have to do for analysis of second group acid radical. So here also draw 3 columns. One is test, observation, then inference. Fine. Let us do the test. I will take a salt in the test tube. To this, I will add concentrated H2SO4 solution. When I add concentrated H2SO4 solution, you have to see the changes taking place. See, when I added concentrated H2SO4, you can see a dense fine fumes which is evolved and pungent in nature. So, this indicates the presence of chloride. When you dip a glass rod in ammonium hydroxide solution, and held it to the mouth of the test tube, you can see a dense white fumes which is evolving. So this indicates the presence of chloride. So after the presence of chloride, you have to confirm the chloride test. That is CT for chloride you have to perform. Next, we will write the test. That is, you have taken the salt and to this you have added concentrated H2SO4 solution. So next observation is pungent smell with dense white fumes is evolved when a glass rod dipped in NH4OH solution is held to the mouth of the test tube. So here in the inference you have to write second group. You have to mention the group as well. Second group, acid radical Cl minus may be present. Cl minus may be present. So after the presence, you have to confirm. That is, you have to perform the confirmation test for chloride. In order to perform the confirmation test for chloride, the test is named as Chromine chloride test. So we'll perform that CT for chloride as well, and we'll see what are the changes taking place. So I'm gonna take salt in a test tube, and to this I'm gonna add potassium dichromate crystals. I have added potassium dichromate crystals. To this you have to add concentrated H2SO4. When you add concentrated H2SO4, you can see orange fumes will be evolved. What you have to do is, you have to take another test tube and you have to invert in this manner. Invert to the mouth of this test tube where the reaction has been taking place. So you have to collect this orange red fumes in another test tube. So to this you have to add NaOH solution, and after adding NaOH solution you have to shake it, and you can see that the NaOH solution will turn into yellow in color. After the solution turns yellow in color, you have to add lead acetate as well as acetic acid and see whether you get a bright yellow PPT or not. So let us do the test and see what are the changes taking place. So I have already taken the salt and I have added potassium dichromate. To this I am going to add concentrated H2SO4 solution. When I add concentrated H2SO4, as you can see that fumes are evolved. You have to collect in another test tube by inverting this other test tube into this reaction which is taking place. So the fumes are already being collected. So I just close the mouth of this, and to this I am going to add sodium hydroxide solution. Okay. When I add sodium hydroxide, just shake it, and you can see the color has been changed to yellow in color. The solution has become yellow in color. So this is a sodium hydroxide solution. To this you are going to add, that is lead acetate as well as acetic acid. So I will add lead acetate solution. This is a lead acetate solution. And next I am going to add acetic acid solution. This is acetic acid. When I add acetic acid, you can see it has changed into bright yellow in color. So I hope all the students can see the changes. So it is bright yellow PPT. PPT in the sense you can see the small particles present in this. So this is yellow PPT. So this itself confirms the presence of chloride. So we have got the acid radical as chloride. Okay, so now how to write the confirmation test for chloride? So you have already written the presence test. That is, first you have done the first group acid radical, then you have performed the second group acid radical. So these are known as presence test, what you have done. So this itself, what you have written is itself consists of another 2 marks. This preliminary test is of 1 mark and this presence test is of 2 marks. Now we have already confirmed that the chloride is present and confirmed. So confirmation test also consists of 2 marks. So totally here 2 plus confirmation test 2 as well as this one, it is of total of 5 marks. So now let us write the confirmation test for chloride. So I am going to write it over here itself. CT for chloride. So the test is observation, inference. So here we have added salt plus K2Cr2O7, that is potassium dichromate. To this we have added concentrated H2SO4 solution. So what you have observed? You have observed that orange fumes evolve. Orange fumes are evolved. So next, after adding concentrated H2SO4, you have taken the other test tube. The fumes are passed in a solution containing NaOH solution. In a solution containing NaOH. Okay. So here what happens when the fumes are passed which contains NaOH solution? So you get NO solution. what is the observation you are getting over here? It is bright yellow PPT. PPT means precipitate. So this itself confirms that chloride is already being confirmed. Chloride is confirmed. So you have to write second group acid radical Cl minus is confirmed. So we have already got the acid radical. Now how to detect the basic radicals? So you have to analyze for the basic radical as well. So before starting the analysis of basic radical, what you have to do is you have to prepare the original solution. Original solution has been prepared by using the solubility test which we have done before. So as you all know that the salt we have taken is soluble in water. So based on the solubility test, original solution has been prepared. So what you have to write is analysis of basic radical. Analysis of basic radical. Before starting the analysis of basic radical, you have to do preparation of original solution. It is also known as OS. Preparation of original solution. What you have to write, that is, original solution is prepared by taking salt is dissolved in water. Salt is dissolved in water based on the solubility and used as OS, and it is used as OS, that is original solution. So now let us do the test, the solubility test. So I have taken more amount of the salt because you have to prepare the original solution nearly 3/4 of your test tube, because you have to detect the basic radical nearly up to 6th group. So you have to do the original solution nearly 3/4 of your test tube. As you all know, it is soluble in water. I am gonna add water to it and make it soluble. So shake it nicely to make it soluble. Yes. So the original solution is already being prepared. So using this original solution, we have to detect for the basic radicals. So shall we start doing the detection of basic radicals? Yes. So this is the original solution. Then the group radicals which you have to detect, that is, it is known as separation of basic radicals into groups. So first group is the 0th group. You have to detect for the 0th group basic radicals. In 0th group basic radical, the first test what you are going to do is, that is not with the original solution. You have to take the salt for the 0th group and then you have to perform the test. So I will take the salt, and to this salt I am going to add NaOH solution. So salt plus NaOH solution. When I add NaOH solution to this, just smell it. Okay. When you smell feel a pungent gas smell of ammonia. Yes, I can feel it, which will hit to your nose. Okay, that itself indicates that it's pungent in nature. So, now, if suppose you can't feel the pungent smell, you can do another test. That is, you take a glass rod and dip in concentrated HCl. So, I've taken a glass rod and I dipped in concentrated HCl and I'm going to held it to the mouth of the test. So, you can feel the dense white fumes. So, you can see the dense white fumes, isn't it over here? Yes, the dense white fumes you can see. So, here, this is the presence of zeroth group. Which is that zeroth group? It is nothing but ammonium ion. So, you get the pungent smelling gas of ammonia when you dip a glass rod in concentrated HCl and held it to the mouth of the test tube. You can see a dense white fumes. This indicates the presence of ammonium ion. Okay, so how to write this in? Yes. Separation of basic radical into groups. So, first I have already told group 0. So, make a column. This will be group number. Next comes the test. Next comes the observation. And then the inference. Okay. So first we have detected for the 0 group. So you have to mention 0 over here. Fine. Test. Go for the test. What we have added? We have taken the salt plus we have added NaOH solution. Okay. When we added NaOH solution, you can smell the pungent smelling gas of ammonia. Pungent smelling gas of ammonia. Then dense white fumes are evolved when a glass rod dipped in concentrated HCl solution. Dense white fumes are evolved when a glass rod dipped in concentrated HCl solution. So what is the inference we are getting? 0 group. Basic radical ammonia. Ammonium ion, that is NH4 plus, may be present. NH4 plus may be present. So we have got that it might be NH4 plus, ammonium ion. So next what we have to do? We have to confirm and find out the presence of NH4 ion. So let us do the CT for ammonium ion. CT for NH4 plus. It is also known as Nestler's reagent test. It is also known as Nestler's reagent test. So what is the test, observation and inference to this? So let us do it and see what is the changes taking place for the conformation of ammonia. just wash the test tube, and to this you have to add the original solution which you have prepared. So this is the original solution I have taken. To this we are going to add Nestler's reagent. So here this is the Nestler's reagent. I'm going to add the Nestler's reagent. Okay, it's already turned up to brown, isn't it? So I have taken the original solution, I have added Nestler's reagent, and to this I am going to add sodium hydroxide solution, NaOH. So here it will turn into brown PPT, which confirms the presence of ammonia. So the observation what you have got is brown PPT, and the inference is confirmation of ammonium ion. So over here you are taking the original solution plus you are adding Nestler's reagent, and to this Nestler's reagent you have been added NaOH solution. Okay, so you got brown precipitate, that is brown PPT. So NH4 plus ion is confirmed. NH4 plus ion is confirmed. So here you get 2 marks for the confirmation of NH4 plus ion, and the presence test what you are doing it, original solution as well as the presence test what you have done is of 2 marks. So here 2 plus 2, that is of 4 marks. Now we have already got the acid radical as well as the basic radical. Now the next thing what we have to do is we have to report it. It is important, students, that you report which salt is given to you. Okay, so to report also you are going to get 1 marks for that. So how to write the report? So report, the given salt contains, the given salt contains, so you have to make columns. This is acid radical and this is basic radical. Acid radical, basic radical. Next thing, which group it is present. So acid radical which we have got, that is chloride. Chloride was present in second group. Basic radical we have got for 0 group. Okay. So you have to write the formula as well. Chloride and NH4 plus. Then write the name, that is chloride. And this is ammonia. Okay, this is the tabular column what you have to do, and lastly you have to write the given salt. The given salt is write the name. First you have to write the basic radical. So that is ammonium chloride. Ammonium chloride with the formula as NH4Cl. With the formula as NH4Cl. So here we have done acid radical, basic radical, and then we have found out that the given salt is ammonium chloride. So students, I hope you have understood the test for this simple salt, and you know the total marks allotted to this salt detection is of totally of 10 marks. Okay, I hope you have understood, students.